So rational expressions have this form. So you have a polynomial divided by a polynomial. A polynomial divided by a polynomial. So most of what you're going to do in the next week and a half or so with rational expressions is looking at expressions that look like this, like you had. These are examples of rational expressions. They look like fractions, but they're polynomials. So x squared minus 2x divided by 3x minus 5. That's a rational expression. You have a polynomial divided by a polynomial. They contain variables. But 2/3 is also a rational expression, and it does not have any variables. It's a rational number, but it's still an expression. All right, so a rational expression is where you have a polynomial divided by a polynomial. And remember, a polynomial can be one term, one or more terms. So one term, one term. You could also see something like 3x minus 5 divided by 2. That's a rational expression. So all these are rational expressions. And as you go through the next week or two, you're going to see all these rational expressions and what they look like. One of the things you got to remember, though, is that in a rational expression, you can't divide by 0. You cannot divide by 0. So if we look at 5 divided by 0, remember that's undefined. So in a fraction, your denominator can never be 0. So before we look at some problems, so we now know what a rational expression looks like. And we know that in a rational expression, we cannot divide by 0 because 0 is where this fraction is undefined. So when I look at number 1 right here, so topic 11, number 1, it says this: find any values of the variable that makes this rational expression undefined. Well, remember, a rational expression is undefined when the denominator is 0. It doesn't matter what the numerator is, because I can have 0 divided by 6, and that's fine. That's 0. That's not undefined. It is undefined when the denominator is 0, not the numerator, just the denominator. So if you want to find the values of x that make this rational expression undefined, all you do is this. You take the denominator, which is x squared minus 6x plus 8, and you set it equal to 0. Don't worry about the numerator. I don't care what the numerator is. A rational expression is undefined when the denominator is 0. So remember, it's undefined when the denominator is 0. So now this looks like solving equations. So you can do this by factoring. So you're going to factor this. And so you're going to, let's see, what's going to work. So it'll be x times x. The last sign's positive, so that means these signs in here are going to be the same, and they're both negative. And the only thing that's going to work is 4 and 2. So I get x minus 4 times x minus 2. And then I'm going to set each one equal to 0. And then you get x to be 4 and x to be 2. So what I found is this. I found that when x is 4, this equation, this expression here is 0, which means my denominator is 0. So that makes this undefined. Also, when x is 2, this is 0, which means this expression is undefined. So the expression is undefined when x is 4 and when x is 2. Now let me kind of show you that that's true. So we have this rational expression. So x plus 7 divided by x squared minus 6x plus 8. And I want to show you 4. So when x is 4, and I substitute 4 into here, I want to show you something real quick. When I substitute 4, I get 4 plus 7 divided by 4 squared minus 6 times 4 plus 8. Well, 4 plus 7, the numerator, is 11. The denominator, 4 squared 16, 6 times 4 is 24, so you get 16 minus 24 plus 8. And I want you to see this. 16 plus 8 is 24. 24 minus 24 is 0. So what I have here is 11 divided by 0, which is undefined. And so that's why 4 makes this rational expression undefined, because it makes my denominator 0. And the same thing is true for 2. If you were to do the same thing for 2, you do all this work, you can get 0 in the denominator. And so that's all you do. So if you want to find out where a rational expression is undefined, you just look at what makes the denominator 0. Now, when we get into graphing rational expressions, we're going to come back to this because that 4 and that 2 do mean something later on. And you're going to see what that is as when we get to that point. So number 2, though, it says this: evaluate the expression for the given value of the variable. Well, see this right here? That's kind of like the same thing here. So when I showed you what the value of the denominator is when x is 4, all I did was wherever I saw the variable x, I substituted 4. And so the numerator, I got 4 plus 7, which is 11. And the denominator, wherever I saw the x, I substituted 4. And then I just went ahead and did the operation. So 4 squared 16, 4 times 6 is 24. So I got 16 minus 24 plus 8, and that's 0. So you got 11 over 0. Do the same thing here. So now remember, this is negative, so you got to be careful. So if you want to evaluate this rational expression when x is negative 2, all you do is substitute. So just substitute. And so you're going to say this. You're going to say negative 6. See, there's no variables in the numerator, so this stays negative 6. Divided by, now that's negative, right? So put that in parentheses. Negative 2 in parentheses squared plus 8 times negative 2. And then minus 2. And then notice what I get here. I get negative 6 divided by negative 2 times negative 2 is 4. 8 times a negative 2 is a negative 16 minus 2. And then look closely now. 4 and a negative 16 is a negative 12. And a negative 12 and a negative 2 is a negative 14. Don't stop there, because you all need to know that a negative divided by negative is a positive, and then 6/4 reduced is 3/7. And so that's the answer. So when you evaluate this expression and you substitute negative 2, you get 3/7. And that's all you do. So number 1 was asking you to find where this expression is undefined. So it's undefined when that denominator is 0. So this goes back to what we did in topic 10. So topic 10, remember, was solving an equation by factoring. And so these numbers right here, these values, if you substitute in here, will make this denominator 0. That idea is the same here. So all you do is just substitute wherever you see the variable x, just substitute negative 2, and they just want to evaluate it. They didn't ask you where this is 0. They just want to know what is this whole thing equal to when you substitute negative 2 in place of x. All right, so that's number 2. Let's look at number 3. So number 3, we have this idea now. So now what we're going to do is we're going to simplify each expression. So let's go to C first, and then we'll come back to these. So to simplify an expression, the first thing you're going to do when you have a polynomial divided by polynomial is you're going to, step 1, you're going to factor numerator and denominator. Okay, you're going to factor numerator and denominator. So if you look at C, the numerator, and remember, if you cover up the denominator here, so from the last 3 weeks, you know that you could factor out a 3 here. So this becomes 3 times x plus 2, okay? And then if you factor the denominator, that's a trinomial, so let's go to the two binomials now. So that becomes x plus 7 times x plus 2. So that product is this. So I factored, so step one is to factor numerator and denominator. And I did that. Step two is to reduce common factors. Reduce common factors. So for example, if I look at this idea from something you may remember a while back, if I have 8 divided by, let's say, 10, 8 divided by 10, I can reduce this because both of these have a 2 in common, have a 2 as a factor. So 8 divided by 2 is 4, 10 divided by 2 is 5. So I can, and then we know that's true because I can write 8 as 4 times 2, and I can write 10 as 5 times 2, and notice 2 divided by 2, those divide out. Okay? They're the same factor. So you divide those out, and you get 4 times 1 is 4, 5 times 1 is 5, which is what we had here. That idea applies here as well. You see you have that x plus 2 as a factor. I see an x plus 2 as a factor as well, so I can divide those out. Now, one thing I gotta tell you, whenever you cross them out, remember, you see, I didn't just cross these out. I said when I cross those out, 2 divided by 2 is 1. 2 divided by 2 is 1. So you're left with factors of 1. So make sure you cross these out, you do realize that those are factors of 1s that you're left with. Kind of makes sense, right? Because if I go here, 2 divided by 2 is what? 1. And that's what you see here. 1 divided by 1 is 1. And now all you have left is this. So step three is to write the answer as factors. So we get 3 times 1 is 3. X plus 7 times 1 is x plus 7. So there's your answer. And so that's how you do simplifying each expression. So the first thing you're going to do is you're going to factor the numerator, factor the denominator, reduce your common factors, and then your final answer. 3 times 1 is 3. X plus 7 times 1 is x plus 7. Kind of like we did here. 4 times 1 is 4. 5 times 1 is 5. All right, let's look at this one. So I will come back to these in a little while. Let's look at this one. So the first thing you're going to do is you're going to factor the numerator. So notice I can factor out of 4. So I get 4 times t plus 5 divided by, now this is a difference of 2 squares, so you got to factor that. So that becomes t minus 5, t plus 5. So first thing I did was I factored. The next thing you're going to do is you're going to reduce your common factors. So notice that my first factor I see is a 4. There's no 4 down here as a factor, but I do see a t plus 5 as factors. So those divide out. I'm left with factors of 1 because t plus 5 divided by t plus 5 is 1. And then your final answer is 4 times 1 is 4. T minus 5 times 1 is t minus 5. Okay? Let's see if I want to go to number 6 next. Let me find another page. Or not 6, but E. Okay, before we do E, let's look at this one. Okay, so there is something called opposites. Opposites. And as you go through the lessons, you're going to see what opposites are. So 2 and negative 2 are opposites. 2 and negative 2 are opposites. If you look at this in terms of a number line, they're on opposite sides of the number line in equal distance. In particular, though, if I divide two things that are opposites of each other, two factors that are opposite of each other, notice what happens. 2 divided by negative 2 is negative 1, right? So when we do these letter B, when we talk about letter B, I want you to think about the idea of opposites. So So I'm going to come back right here. I'm going to rewrite this as 2 divided by negative 2. And let's go ahead and reduce. When we reduce, we say this is 1 and this is negative 1. And 1 divided by negative 1 is negative 1, which is what we said it was supposed to be. Now, let's look at this. I need for you to see that the opposite of x minus 2 is, and all you do is change the signs of each term. See, 2, negative 2. This has 2 terms though, so x, negative 2, positive 2. So the opposite of x minus 2 is negative x plus 2, which I can write as 2 minus x. So x minus 2, 2 minus x. Those are opposites. If I divide those, if I say x minus 2 divided by 2 minus x, since those are opposites, just like these were, those are opposites, you need to know that that quotient is going to be a negative 1. So you see right here, x minus 2, the opposite of x minus 2 is a negative x and a positive 2. So that's directly going to be negative 1. So that reduces to negative 1. Now here's why that's true. I want to show you something. So I'm going to leave the numerator as x minus 2, and in the denominator, I'm going to factor out a negative 1. Just kind of show you this. I'm going to factor out a negative 1. So negative 1 times a negative 2 is a positive 2. A negative 1 times a positive x is a negative x. So this right here is this. I want you to see this. This x minus 2 and negative 2 plus x are the same thing. X, negative 2, negative 2. So those reduce and gives you 1. 1 divided by negative 1 is negative 1. So in particular, you need to know that if you're dividing two polynomials that are opposites of each other, right away, their quotient's negative 1. So right here, all you have to say right away is that this is negative 1. Negative 1 because those are opposites. 3 minus x and x minus 3 are opposites. Okay? Now that's going to take us to E. So let's look at E. So in E, we're going to simplify this rational expression. The first thing you're going to use is factor. So I can factor out a 6. So this is 6 times x minus 7 divided by, this is the difference of two squares. Now leave it like this. Don't change it around. So when you factor this, you get 7 minus x times x plus, times 7 plus x. So 7 minus x times 7 plus x. Now, reduce any common factors. I see a 6, there's no 6 down here. I see an x minus 7, there's no x minus 7 down here, but do y'all see any opposites? What is the opposite of x minus 7? The opposite of x is negative x. The opposite of negative 7 is positive 7. So these are opposites. So that means that when you divide them out, you get negative 1. So my answer now is this. 6 times negative 1 is negative 1. 1, and then that's negative 1, and that's 1 down here. 1 times 7 plus x is 7 plus x. So there's your answer. Now, if you want to, you can say negative 1 divided by, and then rewrite this as x plus 7 does not matter. But you got to now think of opposites. So you got to look at opposites. So when you divide opposites, you get that negative 1. And let me show you. You get one of them to be 1 and one to be negative 1. So you get negative 1 over 1 or 1 divided by negative 1. We tend to put the negative in the numerator. Okay, let's look at this one. So over here, we're going to simplify this. Now, many students get themselves into trouble because here's what they want to do. They want to say x into x squared. You cannot. You can only reduce factors. So you must factor first. You cannot say 4 and 12 is 1 and 3. You cannot do that because 12 is not a factor. So you can only reduce factors. So what you got to do first is you got to factor the numerator and factor the denominator. So when I factor, the denominator is easy. So let's do that first. When I factor the denominator, I get 3 times x plus 4. Okay? So you got to do that first. The numerator, when you factor that, that's going to be 2x, x, and for 4, let's try 4 and 1. So make this 4, this 1. The last sign's negative, so these have to be different, and I need the 7x to be positive. So it has to be positive, this has to be negative. So it turns out that this is this. Now do you see what you can factor out? I'm sorry, that you can reduce? You have common factors, right? So you say, that's 1, and your answer is 2x minus 1 times 1 is 2x minus 1. 3 times 1 is 3. And there's your answer. Okay, letter G. All right. Again, don't say I'm going to cross these x squareds out. You cannot, because those are not factors. Factors are separated by products. This is not a product right here. This is an addition. So you got to factor first. So you got to factor the numerator, factor the denominator. So the numerator, when you factor that, now the GCF in both cases is 1. But when you factor that, that's going to be 3x, x, and let's put the 2 here, the 1 there. The last sign's negative. These signs have to be different, and I want the middle sign to be negative, so that means this has to be negative, this has to be positive. You can always check. 3x times negative 2 is a negative 6x. 1 times x is a positive x. When you add them up, you get negative 5x. And the denominator, you get x minus, let's see, I think it's x plus 5, x minus 2. So that is this. And notice these are your common factors, so those divide out. 1's in their place, factors of 1. And your answer, now don't leave it like this, because you got to rewrite this without this information here. Your answer is 3x plus 1, and then x plus 5 times 1 is x plus 5. That's your answer. All right, H. Now, you had this, you factored these kinds in previous lessons before, the previous 3 weeks. You have 2 variables, so don't let that throw you off. So when I factor the numerator, though, let's see, the GCF in both cases is 1. So over here, let's see, that's going to be x, 6y, let's try 3y and 2y. And the last sign's negative, so these have to be different, and I want the middle sign to be negative. So that means this has to be negative, this has to be positive. The denominator, this is 2x, x. For 3y, let's put the 3y here and the y there. The last sign's positive, and they're both negative. All right, and then notice I have an x minus 3y here. Do you see an x minus 3y in the denominator? Yes. So those divide out. Now be careful. Some students seem to think that these are opposites. They're not, because this is an x. The opposite of x is a negative x. There's no negative x down here. Okay, so you can't do anything else. You're done. So the answer is 1 times x plus 2y is x plus 2y, and then 2x minus y times 1 is 2x minus y. And that's your answer. Okay, now let's go back to letter A right here. You see, the difference between A and all of these others is that these are all monomial factors. 22 times x to the 4th times y squared. 8 times x squared times y to the 5th. So the way I would do that, if you're kind of struggling with that kind of problem, is this. Let me go ahead and rewrite it over. So this is the way I would do that. 22x to the 4th y squared divided by 8x squared y to the 5th. Look at 22 divided by 8 first. 22 divided by 8. So I can reduce that. They're both divisible by 2. So that's going to be 11/4, right? Okay. Now, look at this right here. You have factors of x, factors of x. So that's x to the 4th divided by x squared. All right, now I want you to think about this for a moment. X to the 4th means x times x times x times x. X squared means x times x. And all you do is just reduce your common factors. And all you're left with is 1 times x, which is x squared, and divided by 1 times 1, which is 1. So this becomes x squared divided by 1. This right here is this. And then over here, where you had y squared divided by y to the 5th, remember y squared means y times y. Y to the 5th means y times y 5 times, right? And then you reduce. The y's divide out, these y's divide out. Now be careful. 1 times 1 is 1, so 1's in the numerator. And in the denominator, 1 times y times y times y times y is y cubed. So it becomes 1 divided by y cubed. Now put that all as one fraction. 11 times x squared times 1 is 11x squared. 4 times 1 times y cubed is 4y cubed. And that's the answer for number 3A. So that was 11x squared divided by 4y cubed. Okay? All right, so that is, y'all, that is topic 11. So we did quite a bit today. It is 2 minutes after